Okay, hi guys. So today we are going to do two things. This video is going to be all about limiting reactant problems, and then my next video will be about gas stoichiometry. So first, limiting reactant is easier to understand if you relate it to a recipe and then think about it in chemistry terms. So if this is my recipe for cookies, or part of a recipe, and I say I need 3 cups of flour and 1 cup of sugar to make 15 cookies. Okay, that's the recipe in the recipe book. At home, let's say I have 3 cups of flour in my pantry, and I have, let's say 2 cups of sugar though. How many cookies can I make with 3 cups of flour and 2 cups of sugar? So think about that for a second, and let's think about what is the determining factor here that's going to tell me how many cookies I can make. So you should be thinking 3 cups of flour will make me 15 cookies, right? So 3 cups of flour is going to make me 15 cookies. How much is 2 cups of flour going to make me? Or 2 cups of sugar, I'm sorry. If 1 cup of sugar makes 15 cookies, how much is 2 cups of sugar going to make? 2 cups of sugar should make me double that, so 30 cookies, right? Because it's going to double my recipe if I have twice as much sugar. So, but think now. I can make 15 cookies with this, 30 cookies with this. How many cookies am I really going to be able to make? Hopefully, you realize that I can only make 15 cookies. And this is because my flour is limiting me on how much I can make, because it's my limiting reactant. Okay? So I have just enough to make 15 cookies, and then I've used up all my flour, so I cannot go on to make 30 cookies with my extra cup of flour or sugar. Okay? Same idea with chemistry. However, chemistry seems harder because we're working with multiple units. So I'm going to give you another example here. Let's say I have 120 grams of flour and 120 grams of sugar. How many cookies can I make? In order to determine this, what would I first need to do? Hopefully you realize that my recipe is in units of cups, right? And this is giving me grams. So first, if I were to solve this type of problem, I would need to convert grams of flour to cups and grams of sugars to cups before I can do that, before I can relate it to my actual recipe. Okay, so that's the same idea as what we're going to be doing today. So I want you to get out your limiting reactant, and sometimes it says reagent. Those words are interchangeable, so just make sure that you know that. Limiting reactant worksheet, and we're going to do number 1 together. Then I'm going to let you do the rest. So, another thing that you should be practicing continuously and making sure that you are checking up on is that you are practicing writing reactions. So your test over this, you will have to write your own reactions. So make sure that that's a skill that you have not lost from last unit, okay? So we have, number 1 says, when copper 2 chloride reacts with sodium nitrate, copper 2 nitrate, and sodium chloride are formed. So hopefully you can identify this as a double replacement reaction. We're going to write and balance our own reaction, or our own equation here. So we have copper 2 chloride, again, plus 2 minus 1 here. So if we drop and swap, copper 2 chloride and sodium nitrate, so sodium and nitrate, sodium is plus 1, nitrate is minus 1, those cancel. We are going to make copper 2 nitrate. So hopefully when you drop and swap, you would have done that. And sodium chloride. +1, -1, those cancel. Okay, now if I was to balance, I have 2 chlorine here. I would need 2 chlorine here, then 2 sodium and 2 nitrate. I'm going to put a 2 there to balance. And that's my final balanced reaction for this problem. Now, moving on to the actual problem part, okay? B says, if 15 grams of copper 2 chloride, so I have 15 grams of this, reacts with 20 grams of sodium nitrate, how much sodium chloride can be formed? If it asks how much, you can go to moles of that substance or you can go to grams of that substance. Okay, it doesn't matter. If it specifies that you're trying to get to grams or moles, then that's what unit you have to go to. If it just generally says how much, then you can choose moles or grams because it's not giving you a specific unit. So for this one, I am going to go just to moles because it's a shorter problem, okay? So how much sodium chloride? So let's see, how many moles of sodium chloride are we going to make? Now, limiting reactant problems are easy to identify because you're not only given one amount of a substance, you're given 2 amounts of substances to start with. So hopefully on this sheet, you realize that you have to underline 15 grams of copper 2 chloride and you have to underline 20 grams of sodium nitrate. And then you should circle how much sodium chloride. So you have 2 things underlined, 1 thing circled, and that's how you can easily identify a limiting reactant problem. And hopefully you've been keeping up with that underlining and circling as I've been telling you to do throughout these units because it makes it a lot easier to determine what type of problem you're working with. Okay? So once we know, okay, this is a limiting reactant problem, I'm trying to figure out which one of these is going to run out first, which is going to determine how much sodium chloride I can make, okay? Just like my sugar and flour example. For every limiting reactant problem, you're going to set up 2 separate Stoich problems. And then you're going to compare those 2 Stoich problems, okay? For this one, my first Stoich problem for this example is going to go from 15 grams of copper 2 chloride to moles of sodium chloride, okay? So with this, I'm going to do a grams to moles problem, and that's going to take me to moles of sodium chloride. So first step, I am going to take molar mass of copper 2 chloride and then mole ratio because my mole or my grams to moles problem tells me on my mole wheel from grams to moles, I use molar mass, then mole ratio. Now let me grab my calculator really quick. All right, so my molar mass of copper 2 chloride, I believe is 134.5, but I will double check that. It is 134.5. So I have 134.5 grams of copper 2 chloride, and 1 mole goes on top because I am trying to cancel those grams. And then my last step is to use mole ratio here. I'm trying to get to moles of sodium chloride. So my moles of sodium chloride goes on top. My moles of copper 2 chloride goes on bottom so that cancels out. My final answer is 0.223 moles of NaCl. So this first step tells me, okay, if I have 15 grams of copper 2 chloride, I can make 0.223 moles of sodium chloride. So that's what I know so far. However, I have 20 grams of sodium nitrate also. So I need to see how much sodium chloride is 20 grams of sodium nitrate going to make? So my second problem here is going from 20 grams of sodium nitrate to moles of sodium chloride, and then I'm going to compare my answers. So I have 20 grams sodium nitrate. And again, this is going to be a grams to moles problem. Same idea here. So I'm going to use the molar mass of sodium nitrate. Let me do that really quick. So I have 85 grams goes on bottom, because that's my molar mass of sodium nitrate. And my 1 mole goes on top, so that these units cancel. And then my mole ratio is my second step here. So I'm going to sodium chloride. So 2 moles sodium chloride on top, 2 moles sodium nitrate on bottom. And final answer is 0.235 moles of sodium chloride. So this is telling me, this whole problem is saying, if I have this much copper chloride, I can make this much sodium chloride. And if I have this much sodium nitrate, I can make this much sodium chloride. So which one of these two is going to limit me on how much sodium chloride I can make? The key here is that it's just the one that makes less. So whichever one of your reactants makes less product, that one's going to limit you, and that's going to be your limiting reactant, and that's going to be your answer. So here, my copper 2 chloride makes less product. It makes less sodium chloride. So my answer, if I look how much sodium chloride can be formed, your answer is 0.223 moles. That is not your answer, okay? So 0.223 moles is your final answer for A, or for B on number 1, okay? And then C says, what is your limiting reactant for this problem? The answer to that question, the answer to C, is going to be copper 2 chloride is your limiting reactant. That's the one that's limiting you to how much product you can make. And it is not always going to be the one that's just less to begin with. Okay, that's just a coincidence. It might be more, but it's just you have to do this work to determine what it is. Okay? Now, D on the front of this says how many grams of copper 2 nitrate is formed. Once you have determined which reactant is your limiting, that's the reactant that you use for any further problems, okay? Because that's the one that's your determining factor on how much of any product you can make now. So the next problem, D, is now asking you, okay, it's saying how many grams of copper 2 nitrate is formed. So now this is our copper 2 nitrate. How many grams can we make of our copper 2 nitrate? So now you can see that this is our starting, because that's our limiting reactant, that's going to determine how many grams of copper nitrate I'm going to make. So this is going to be a grams to grams problem, and I'm just going to set it up like I know how. I no longer have to use this one because that's not my limiting reactant, so I ignore that for right now. So I have 15 grams of copper 2 chloride, and I'm going to grams of copper 2 nitrate here now. So I'm going to do mole ratio, molar mass, mole ratio, molar mass. So I'm going to do 134.5 grams of copper 2 chloride and 1 mole of copper 2 chloride. Cancel. And then I'm going to do mole ratio. So since I'm trying to get to copper nitrate, ratio on top for that. Molar ratio copper chloride on bottom so that these two cancel. And then finally, my molar mass for copper 2 nitrate. So let me calculate that really quick. Which is 187.5 grams of copper 2 nitrate on top, and my 1 mole on bottom, so that those cancel. Okay. So hopefully you can see that this is a grams to grams problem. My final answer is 20.9 grams of copper 2 nitrate for D. That's saying with my limiting reactant, I can make 20.9 grams of this product. Okay, now E. E is probably the hardest for students to understand and remember how to do. So if you ever need another refresher on how to do excess reactant, come back to this video and make sure you're looking at your limiting reactant video, and I will explain how to do excess reactant, or how I teach excess reactant. Some teachers might teach it a little bit differently. That doesn't mean it's wrong, or that doesn't mean I'm wrong or they're wrong or whatever. It just means it's different. So if you go to another chemistry teacher for help, or if maybe your sub helps you in some other way, it's not necessarily wrong if you get the right answer. It's just a different way to go about it. So I'm going to teach you how I teach my classes how to do excess. Okay? So in order to find out how much excess reactant we have, remember, this is my limiting reactant. This one is in excess, meaning I have too much of it, right? So I am going to figure out how much of this is left over once I use up all of my limiting reactant, right? So I'm going to take my limiting reactant and convert it to grams of this to see how much I'm going to use of this. And then I'm going to take that number and subtract it from how much I actually have. So I'm going to take 15 grams of copper 2 chloride, and I'm going to convert it to grams of my excess reactant. So a grams to grams problem here. So again, molar mass molar ratio. This is what I'm trying to get to. Okay. And then molar mass again, which I already forgot what that is because pregnancy brain here. So I have 85 grams and 1 mole. So that these units cancel, these units cancel, and these units cancel. So I have 15 grams, 1 mole over 134.5 grams, 2 moles over 1, 85 grams over 1. Those are my numbers in case you can't see them. I think that they're okay, but just in case. So my final answer here for excess is 18.9 grams. So let's go back and think about what this question is asking. It's asking how much of this am I going to have left over once I use all of this up? This work, what I just did, was converting my limiting reactant amount to my excess and seeing how much I'm going to use. So with 15 grams of my limiting reactant, I am going to use up 18.9 grams of my excess reactant. How much is left over then? If I use 18.9 grams of this, how much is left over? Hopefully you realize 20 minus 18.9 is 1.1 grams of sodium nitrate left over, of my excess left over once I use what I need to react with my limiting. And that's how you work out an excess problem. You take your limiting reactant and convert it to your excess reactant and then subtract it from how much you originally are given. And your answer is 1.1. Make sure that this is not your answer. You have to do that subtraction to figure out how much is left over. Okay? That was a lot for limiting reactants. The back is the exact same setup. So I want you guys to work through these problems, and then you should have a few homework problems for limiting reactant problems. These are the longest problems you're going to do. So they're always going to involve multiple steps and grams to grams, which are your longest types of problems. So just make sure that you follow this video guideline for any questions you may have. Good luck, guys.